All right, expanding logarithms. Now, before we can talk about this section, sort of like in the last one, we had to talk about negative exponents before we could talk about it. This section, we really need to talk about rational or fraction exponents. Rational means fraction. When you hear the word rational, it means fraction. So review of rational exponents. Whoop, whoop. When you have something like this is the nth root of x raised to the m. The way we rewrite this radical as an exponential is by taking the power, and that becomes the numerator. So the power on the inside becomes the numerator of the exponent, and then the root becomes the denominator of the exponent. Right? We're going to do some examples. You'll see several examples down here. We're going to do examples. But let me do highlighting here, right? The root becomes the denominator. The power becomes the numerator. And then the root becomes the denominator. I just got a phone call, got interrupted in the middle of a word. All right. The power is the numerator of the exponent. The root is the denominator. One of the favorite things I have heard a colleague say when she talks about rational exponents is it's the powers above and the roots below. So if that helps, powers above, the powers above, and the roots below. I think that in my head all the time now. The other important thing you need to know is that when you take a square root of something, there's this invisible little 2 that just we don't write. All right. It's sort of like with log base 10. If it's base 10, we assume logarithms are base 10. So with base 10, we don't even have to write the 10. We can write the 10, but it's excessive. And it's the same thing with the square root. We don't have to write the 2. We just assume it is. Right, so the square root of x is x to the 1/2 because the power on the x is a 1 and the root itself is a 2. Power 1, root 2. So let's go ahead and rewrite all of these radicals as exponents. So we have x, the cubed root of it, cubed root of x. So x is being raised to the first power and the root is 3. If you want to pause and take a whack at some of these, go ahead and do so now. Okay, you had a chance to pause. Here, the power on x is 5, and the root is 4. All right, let's see, do a little highlighting here. Power, root, root. Here, there's a secret 2 right here. If you don't see a number, it's a 2. If you don't see a number on the root, it's a 2. So this is x plus 2. The power on the inside is 3. The root is 2. So this is raised to the power is 3, root is 2. For fractions, we can give this radical to the numerator and the denominator. So this 5th root, we could give to the numerator and to the denominator. So if we rewrite that, x squared, the 5th root of that, would be x raised to the power is 2, root is 5, 2/5. For the 5th root of y cubed, y has a power of 3 and a root of 5, so raised to the 3/5. For something like this, where you don't see a power on the inside, that's just going to be w plus 1 raised to the first power. The whole thing is raised to the first power. And then it's the cubed root of the whole thing. Right? So if there's, here it's a lot easier, I think, to see that it should become 3/2. But here, I think it's really easy to want to make it like w to the 1/3, 1 to the 1/3. But we can't do that. There's secret parentheses holding together everything on the inside there. All right, with this last one here, we have the cubed root of w plus 1 squared all over x to the 5th. So this is going, oh, I did not leave myself much room here. Let's come down here for a moment. So this will be the cubed root of w plus 1 squared all over the cubed root of x to the 5th. And if I rewrite that, I get w plus 1 raised to the power is 2, root is 3, all over x raised to the power is 5, root is 3. And there you go. Let's do a few moving in the backwards direction. It won't take us too long, right? So here, remember, powers above, roots below. Powers above, roots below. So this is a 5th root of 2x minus 1 raised to the 3rd power. X raised to the 5/2. That's 2 is a square root. I'm going to write it that way at first. Square root of x raised to the 5th. The square root is unnecessary, so we will just write x to the 5th with the radical, but not the 2. For 2 to the 1/2, the power is 1, the root is 2. So we have the square root of 2 raised to the 1, which is just the square root of 2. So the way we write square root of 2 as an exponent is 2 raised to the 1/2 power. Anytime you see a 1 in that in the numerator of an exponent, it's just going to mean you're just taking a radical of it, right? So like here, we ended up with a 1 because there was no power on the inside. Here, there was no power on the inside. We had a 1. So this is going to be the cubed root of x plus 1. The whole thing is raised to the first power. That means it's just x plus 1. All right, so that's rational exponents for you. That's going to come in handy here as we talk about expanding logarithms. So expanding a logarithm, what does that mean? When we expand a logarithm, we use logarithm properties to break a single logarithm up into as many terms as possible. So we want to expand it as much as possible. And really, we're using these guys over here. All right, this is really what gets used. These are what help us break it up into as many pieces as we can. I want you to remember multiplication on the inside turns into addition on the outside, division on the inside turns into subtraction on the outside, and that exponents on the inside can come down in front. That's what's important here. So log base 10 secretly, log of y divided by x squared. This we can use rule number 7. So this is log of y minus log of x squared. So it's not for expanding. I should have wrote this on the worksheet. These are new worksheets. Pretty excited about them. It should also have said on here to bring down any exponents. Right, so I've broken them up, numerator, denominator, right? So m and n, same thing. This 2 on the inside right here, I can take him, I can bring him down in front of this logarithm. I get log of y minus 2 log x. So log of y divided by x squared is equal to log of y minus 2 log x. That's as expanded as we can make it. Let's look here. So we have log base 2 of the square root of z to the 7 x. I'm going to start by rewriting all of this with rational exponents. With multiplication, we can distribute the square root over both of these separately. And then I can write this with rational exponents. So for z, the power is 7, power above, and then the root is 2. Then x, and it's not a plus, right? These are being multiplied. These are being multiplied because they're right next to each other. X is being raised to the 1/2 power. Multiplication on the inside turns into addition on the outside. So this is log base 2 of z raised to the 7/2 plus log base 2 of x to the 1/2 power. This is by rule number 6. This guy right here, we used rule 7, and then we used rule 5. If you're looking up at the log properties up above, here, we used rule 6. And then we can bring these exponents down in front. So this is the kind of game we're playing. It's multiplication turns into addition, bring the exponents down. So we get 7/2 log base 2 of z, the exponent came down, plus 1/2 log base 2 of x. That's by rule 5. For nearly all of these, the last step is bringing down those exponents. We try to break it up into as many pieces as possible, then bring down the exponents. These log properties are going to be really, really useful for you once you get into calculus. I promise this all comes back and becomes incredibly relevant in calculus. Taking the derivative of this is hard. Taking the derivative of this, surprisingly easy. Fun stuff happening. Let's make it a teeny tiny bit harder, right? So, we got this stuff in the numerator. It's a really ugly highlight, but that's fine. We got this stuff in the denominator. ln is just log base e. It follows all the rules of log properties. So good here. Division on the inside becomes subtraction on the outside. So I have ln of x plus 5 squared minus ln of zw squared, right? You are not done here, and you're not done if you take this exponent down either. We've already talked about in a previous problem why we can't take the 2 down. I think we talked about that on like day 1, or video 1, the first video of this section. We can't just take down this 2 because the z doesn't have the 2 on it. We're going to need to break this guy up further because there's more we can do. There's multiplication in here. These z's and w squareds are multiplied together. Multiplication on the inside becomes addition on the outside. It needs to be done very, very carefully. This is all still being subtracted, so I'm putting in parentheses here. We have ln z plus ln of w squared, right? If I take this multiplication, I can turn it into addition on the outside, but it still keeps the minus sign. So here we used rule 7. Here we used rule 6. And then I'm going to do a few steps. I'm going to take the exponent and I'm going to move them down in front. So I have 2 ln of x plus 5 minus ln z plus 2 ln w. And then I'm going to distribute the negative. I get 2 ln of x plus 5 minus ln of z minus 2 ln w. Bam. This was rule 5 here, where we taking down the exponents is rule 5. So from here to here, we applied rule 5. From here to here, we applied rule 7. From here to here, we applied rule 6. So this is completely broke down. We brought down all exponents. We separated it into as many pieces as possible. X plus 5 on the inside cannot be separated anymore. Addition on the inside doesn't turn into anything on the outside. It has to stay the way it is. So that's that. Now, that's fun. That's great. I love doing tons of steps. But there's an easier way, right? There's a trick. And if you've printed off this worksheet, you have text here already. I do too. I just wanted to make it a dramatic reveal here. I want to talk about how to do these easily. And I'm going to do so with an example here. So we have ln of a b to the 6th c divided by xy squared z cubed. If I'm breaking this up multiple steps, right, I would be doing, numerator minus denominator. And then I would want to break up each of these pieces. From the numerator, you have your a, your b to the 6th, and your c. It's all addition because you're multiplying them all together. Here, you have your x, y squared, z cubed. That's from the denominator. Minus, and then there's parentheses because this entire thing is in the denominator. So this is all numerator, this is all denominator. If we distribute this negative, right? Minus, 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 minus. And then we bring down exponents. Bring down in front. Bring down in front. Bring down in front. We get this guy right here as our final answer, and I can delete my little square now. We get this right here as a final answer, and I want to point something out. Every variable that came from the numerator, right, a, b, and c came from the numerator, all of those ln's are positive. They have plus signs in front of them, right? These are all positive. And anything that came from the denominator, which is x, y, and z, right? X, y, and z, has a negative in front of it. So factors that come from the numerator, when they're split up completely, are positive. Ones that come from the denominator, when split up completely, are negative. And then it's just exponents in front, right? A is in the numerator, ln a, positive ln a. B to the 6 is in the numerator, 6 ln b, positive. Y squared is in the denominator. 2 should be out front, and it should be a minus in front because y is in the denominator, right? Minus 2 is the exponent, minus because the denominator, ln y. What this saves us from doing is basically every step. I can tell you right now, when I do this, when I expand this, I go from here to here. I don't write any of these intermediate steps. It's a waste of my time, right? If I were doing any of these problems previously, I might have rewritten this guy like this, so I'd have the exponents ready to write, but I wouldn't have split it up into multiple steps where I do the addition and then bringing the exponents down, because I know that I'm going to bring the exponents down. I know that if it's in the numerator, it's going to be positive. If it's in the denominator, it's going to be negative. So here it is kind of all written down. Before expanding, distribute any radicals, rewrite in exponential form. So you want everything in exponential form. And then factors from the numerator become positive, factors from denominator become negative, and exponents come down in front. Right? So if I'm looking at each of these terms, I have a w cubed. That comes from the numerator. So the 3 comes out front. I'll give myself space here. The 3 comes out front, and then we have ln of w. For this next one, w squared plus 1, it's in the numerator, so it gets a plus. There's no exponent to bring down. I can't bring down this 2 because it's not on everything. So it's just ln of w squared plus 1. The plus is because of the numerator. No exponent to bring down. This guy right here could be rewritten as 6 minus w raised to the 3/2 power. Right? 3 is the power, 2 is the root. So in the numerator, so it gets a plus, the power is 3/2. It'll come down out front. ln of just the inside stuff, so just the 6 minus w. ln of 6 minus w. Y to the 8th. It's in the denominator, so it's a minus. The exponent is 8, so it's minus 8 ln y. W plus 1 raised to the 6th is in the denominator, so it's a minus. The exponent is 6 ln of w plus 1. And that is the whole thing broken down. So if I duplicate that, I can erase all my highlighting. And bam, there's my answer. It's a huge shortcut, all right? This saves you a ton of time. Can you imagine how long this would take you if you were writing this step by step? It would take forever. So let's go ahead and use that expansion trick to do a few of these logarithms. There's quite a few listed here. Now is a great opportunity for you to pause and try some of them out yourself. I highly suggest it. You're going to get way more out of this if you do. But if you're still here, if you're ready to talk about it, let's do these. First of all, if there's any radicals, you're going to need to distribute those. So this radical, there are 3 different terms here. So we got, the w squared, we have this guy right here, and this one here. There's 3 different pieces. That radical would go on all of them. So we have log of, this is w, the cubed root of w squared times the cubed root of x plus 6 raised to the 5th power all over the cubed root of x. Rewriting this with as exponentials instead of radicals, this will be w raised to the 2/3 power, x plus 6 raised to the 5/3 power, all over x raised to the 1/3 power. So splitting that up, in the numerator, we have the w to the 2/3, so we have 2/3 log of w. The next thing we have in the numerator, so plus, is x plus 6 raised to the 5/3, so that we have that 5/3 log of x plus 6. In the denominator, minus sign, exponent is 1/3 of x. Bam, done. These are things that look a lot scarier until you see the mechanics of it. The mechanics of it, once you get it going, are a lot easier to deal with. All right, there are 4 pieces in this one, right? 7. This guy here, x plus 6 cubed, this one, and this guy here. There are 4 different pieces. So we're going to have 4 different terms when it's all expanded. The one I need to make sure to rewrite is this guy. So the cubed root of x to the 5th is x raised to the 5/3. I'll just rewrite the whole thing now. I can even put a multiplication symbol in here to help remind me that the 7 is its own term that needs to be separated. So we have x to the 5/3, and then we have x squared plus 1. Note that the x squared plus 1, we will not be able to bring down any exponent because the square is on the inside of it. Okay. So breaking this up from the numerator, we have ln of 7. The next thing in the numerator is x plus 6 cubed. So plus because numerator, 3 is the exponent, ln of x plus 6. In the denominator, minus, we have x to the 5/3. So 5/3 out front, ln of x. Then we have x squared plus 1, minus because denominator, no exponent to bring down, x squared plus 1. Right? Notice the difference between something like x plus 6 cubed and x squared plus 1. Right? Here we could bring down the cube because it was outside of everything. Here, that square is on the inside, so we can't do anything. If there were an exponent out here, we could, but there's not. Bam. Done. All right, for these last 2, I am once again going to be distributing and rewriting these guys, the inside of this, in so that there's no radicals. So this is the square root of x cubed times the square root of z all over y raised to the 5th power. This is log of x raised to the power is 3, the root is 2. For z, the power is 1, the root is 2. And then y to the 5th on the bottom doesn't have anybody. Expanding that, x to the 3/2 is in the numerator, so it's positive. 3/2 comes down out front, log of x. Next one is z to the 1/2, plus because numerator, 1/2 is the exponent, log of z. In the denominator, minus, there's a y to the 5th, 5 is the exponent, log of y. Bam. All right. This last one is very similar to this one, all right, but I wanted to show the difference between if this radical was just in the numerator versus if it was over everything. So if it were over everything, it's going to be very close to this. But there would be a square root on the y to the 5th as well. Okay, if the square root is over everything, you have to give it to every single piece. So this would be raised to the 5/2 instead of being raised to just the 5. So it's going to be this entire answer, but a 5/2 here instead of a 5. Okay. So that is expanding logarithms. It's not so bad. The trick really helps. In our next video, we're going to talk about going the reverse direction. So we're going to talk about starting here and going back up to here. So exciting. I'll see you then. If you have questions, send me an email. Otherwise, see you in the next video. Bye.